Hello friends, welcome to my YouTube channel We Are Scholars. Today we are studying our fourth lecture of electricity. In this chapter we are covering Joule's law of heating and electric power. So let's start. What is Joule's law of heating? We know H is equal to I square RT. So we can define Joule's law of heating with the help of this formula. Right? According to this law, heat produced in a resistor is directly proportional to square of current. That means H directly proportional to square of current, directly proportional to resistance for which given current, directly proportional to R, and directly proportional to the time for which the current flow through the resistor. So H is directly proportional to T, right? I repeat, according to Joule's law of heating, heat produced is directly proportional to square of current, heat produced directly proportional to resistance, and heat directly proportional to time, right? So this is Joule's law of heating. Now, what is the application of Joule's law of heating? Practical application of heating effect of electric current. We have many appliances in which we use heating effect of electric current, right? We use electric laundry iron, we use electric toaster, we use electric oven, we use electric kettle, we use electric heater. In all these appliances, we use heating effect of electric current. Now, we will study electric power 1 watt and 1 watt hour. Okay. Now, what is electric power? It is the rate at which energy consumed in an electric circuit. किसी भी इलेक्ट्रिक सर्किट के अंदर किस रेट से एनर्जी कंज्यूम्ड हो रही है, that is called electric power. We can calculate power with the help of these formulas. P is equal to V into I, power is equal to voltage into current, or power is equal to I square R, current square into resistance, or power is equal to voltage square upon R. It depends upon the value given in the question. If you have IR, you can calculate the power. If you have VR, you can calculate the power. Or if you have simply V into I, you can calculate the power. These values comes from the Ohm's law. If we put the value V is equal to IR, we get I square R. Or if we put the value of I V upon R, we get value V square upon R. So you can use any of the formula. SI unit of power is watt. So unit of power is watt. Unit of current is ampere. Unit of potential difference is volt. And unit of power is watt. So 1 watt is equal to 1 volt into 1 ampere. With the help of this formula, you can define 1 watt. Right? 1 watt, it is the power consumed by a device that carry 1 ampere current when operated at a potential difference of 1 volt. Right? 1 watt power consumed कब होगी? जब potential difference 1 volt होगा और current मेरा 1 ampere होगा. Right? So power is said to be 1 watt when potential difference across the terminal is 1 volt and current flowing in that circuit is 1 ampere. Then power is said to be 1 watt. Right? Now we define 1 watt hour. It is the energy consumed when 1 watt of power is used for 1 hour. Simply, when we use 1 watt power for 1 hour, then it is called 1 watt hour. Commercial unit is kilowatt hour, kWh. So 1 kilowatt hour is equal to, we convert it, 1 kilowatt equal to 1000 watt and 1 hour equal to 3600 second. Now we can write 3.6 into 10 raised to power 6 watt second. So 1 kilowatt equal to 3.6 into 10 raised to power 6 watt second, or 3.6 into 10 raised to power 6 joule. So now we just do some numericals on heating effect of electric current and electric power, right? In this numerical, an electric iron consumes energy at the rate of 840 watt when heating is at maximum rate and 360 watt when heating at minimum rate. The voltage is 220 volt. What is the current and resistance in each case? Here you have two powers, one at maximum heating and one at minimum heating. You have voltage 220 volt. So you have to calculate current required at maximum heating and resistance. Also current at minimum heating and resistance. So for case 1, for maximum heating, P1 is equal to 840 watt, B is equal to 220 volt. This is given. So I1 is equal to P1 by V. This comes from, since power is equal to voltage into current. So current is equal to power divided by voltage. 840 divided by 220. When we divide it, we get 3.82 ampere. When we get the current, now we calculate resistance. R1 is equal to V upon I1. R1 V is equal to 20, I1 3.82. Now divide 220 by 3.82, we get 57.60 ohm. So for minimum heating, power given 360 watt, current power divided by voltage 360 by 220, 18 by 11, 1.64 ampere. With the help of this I2, we can calculate R2. R2 is equal to V upon I2. 220 divided by 1.64. From here we get 134.15 ohm. Right? So let's do our next numerical. In this numerical, 100 joule of heat are produced each second in 4 ohm resistance. Find the potential difference across the resistor. So what we have given? We have given heat 100 joule for a resistance of 4 ohm. Resistance 4 ohm. Each second, time is 1 second. We have to calculate value of V, potential difference. So we know that H is equal to I square RT from Joule's law of heating. I is equal to under root H by RT. So when we calculate the value of I, RT divided by H and square convert to root. So putting the value of heat 100, resistance 4 into 1. We cut the values 25, square root of 25 is 5 ampere. From here we calculate the current. With the help of current and resistance we calculate potential difference V. V is equal to IR. We have calculate I5 and R4. 5 4s are 20 volt. So potential difference is 20 volt. In the next numerical, an electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? Here he is asking power and given potential difference 220 volt and current 0.50 ampere. Right? So we have potential difference and current. We know power is equal to V into I, voltage into current. So 220 into 0.50 is equal to 110 watt. You also calculate like this, 50 divided by 100, that is 1 by 2, that is 110. So it is 110 watt. In this numerical, an electric refrigerator rated 500 watt operates 8 hours per day. What is the cost of energy to operate it for 30 days at the rate of 5 per kilowatt hour? So in this question we have given power of the refrigerator 500 watt, cost of energy at the rate 3 rupees per kilowatt hour. So first, energy consumed when operate 8 hours per day for 30 days. This refrigerator 8 hours per day operated for 30 days. So energy consumed is equal to power into time into number of days operated. So it comes 1,20,000 watt hours. So convert it into kilowatt hour divided by 1000. So it becomes 120 kilowatt hour. Now cost of energy is equal to energy consumed into rate. 120 into 3, that is 360 rupees. So this is our answer. Cost of energy consumed in 30 days by refrigerator is 360 rupees. Now in next numerical, an electric motor takes 6 ampere from a 220 volt line. Here we have current 6 ampere, voltage 220 volt line. Determine the power. What we have to calculate? Power of the motor and energy consumed in 5 hours. So we have to calculate power and energy consumed. First we calculate power. We have I 6 ampere, V 220 volt. Power is equal to voltage into current, 6 into 220. So power comes out 1320 watt, 1320 watt. Now energy consumed. Energy consumed is equal to power into time. Power is 1320 into time 5 hour. So it comes out 6600 watt hour. So convert watt hour into kilowatt hour divided by 1000. So it comes 6.6 kilowatt hour. In this numerical, an electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate heat developed in 30 seconds. So you have given resistance 20 ohm, R, current 5 ampere and time 30 seconds. And you have to calculate heat. We know H is equal to I square RT. Resistance given, current given, time given. So just put the value 5 square into 20 into 30. 5 5 is 25, 20 30 600, 25 into 600, 15,000 joule. So heat produced in electric iron is 15,000 joules. It is very simple. All values you have given in this numerical. Resistance is given, current is given, time is given. And you know by Joule's law of heating, heat produced is equal to I square RT. I square 5 square R 20 T 30. Multiply these values, we get the heat produced 15,000 joule. Right? In next question, compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Right? In this question, you have given value of Q 96,000 coulomb. Time is 1 hour. So convert in second. 1 hour equal to 3600 second and potential difference V is equal to 50 volt. You know H is equal to I square RT. But in this question, we don't have I and R. We have the value of T. So split this formula. IR into IT. IR according to Ohm's law is equal to V. And IT according to first formula which I have studied in first lecture, I is equal to Q by T. So I into T is equal to Q. Right? So we put the value IR is equal to V and IT is equal to Q. Now we have value of V is 50 volt and value of Q 96,000 coulomb. Multiply these value, we get 48 lakh joule. So heat produced is equal to 48 lakh joule. Right? So guys, this is last video of our lecture series electricity. I have covered all the topics of this chapter and even I have also covered every numerical with their examples. So if you like my video, please subscribe my channel and do comment. Thank you.